Good day, everyone. My name is Dorothy Reading Alfrancia, and I'm student 17. I'm going to discuss about the factors affecting highway design under geometric design of highway facilities. So, objectives. First objective is to know what is geometric design. The second one is to know the different factors affecting highway design. So, before we proceed to the different factors, let us first define what is geometric design. So geometric design deals with the dimensioning of the elements of highways, such as vertical and horizontal curves, cross-sections, track climbing lanes, bicycle paths, and parking facilities. The characteristics of driver, pedestrian, vehicle, and road, as discussed in Chapter 3, serves as the basis for determining the physical dimension of these elements. So for example is lengths of vertical curves or radii of circular curves are determined to assure that the minimum stopping sight distance is provided to highway users for the design speed of the highway. So the fundamental objective of geometric design is to produce a smooth flowing and safe highway facility, an object that only can be achieved by providing a consistent design standard that satisfy the characteristics of the driver and the vehicle that use the road. Next is the factors affecting highway design. So highway design is based on specified design standards and controls which depends on the following roadway system factors. So the first one is the functional classification. So highways are classified according to their functions in terms of the service they provide. The classification system facilitates a systematic development of highways and the logical assignment of highway responsibilities among different jurisdictions. Highways and streets are categorized as rural and urban roads depending on the area in which they are located. So the initial classification is necessary because urban and rural areas have significantly different characteristics with respect to the type of land use and population density, which in turn influences travel patterns. So within the classification of urban and rural highways are categorized into the following groups. So the first one is the principal arterials, minor, major collectors, minor collectors, local roads, and street. So here we have the schematic illustration of the functional classes for a suburban road network. So we have arterial street, the commercial area, the local street, collector street, and public area. Then functional system of urban roads, the first one is urban principal arterial system. So this system of highways serves the major activity centers of the urban area and consists mainly of the highest traffic volume corridors. So it carries a high portion of the total vehicle miles of travel within the urban area, including most trips within a region or destinations within the urban area. The next one is the urban minor arterial system. So this system serves strips of moderate length and places more emphasis on land access than the primary arterial system. So all arterials not classified as primary are included in this class. Although highways within the system may serve as local bus routes and may connect communities within the urban area, they do not normally go through identifiable neighborhoods. The next one is urban collector street system. So the main purpose of street within this system is to collect traffic from local streets in residential areas or in CBDs and convey it to the arterial system. So thus collector streets usually go through residential areas and facilitate traffic circulation within residential, commercial, and industrial areas. So next is the urban local street system. So this system consists of all other streets within the urban area that are not included in the three systems described earlier. The Purpose of these streets are to provide access to abutting land and to the collector streets. Through traffic is discouraged in this street. Next is the functional system of rural roads. The first one is rural principal arterial system. So this system consists of a network of highways that serves most of the interstate trips and a substantial amount of intrastate trips. So virtually all highway trips between urbanized areas and a high percentage of trips between small urban areas with population of 25,000 or more are made on this system. The next is the rural minor arterial system. So this system of roads augments the principal arterial system in the formation of a network of roads that connects cities, large towns, and other traffic generations such as large resort. Then travel speeds on these roads are relatively high with minimum interface to through movement. So next is the rural collector system. So highways within this system carry traffic primarily within individual counties, and trip distances are usually shorter than those on the arterial roads. So this system of roads is subdivided into major collector roads and minor collector roads. And the rural major collector system is routes under the system carry traffic primarily to and from county seats and large cities that are not directly served by the arterial system. But the system also carries the main intercounter traffic. So next is the rural minor collector system. So this system consists of routes that collect traffic from local roads and convey it to other facilities. So one important function of minor collector roads is that they provide linkage between rural hinterland and locally important traffic generators such as small communities. Next is the rural local road system. So this system consists of all roads within the rural area not classified within the other system. So this road serves trips of relatively short distances and connect adjacent lands with the collector roads. So the second factor is design hourly traffic volume and vehicle mix. So the traffic volume keeps fluctuating with time from a low value during off-peak hours to the highest value during the peak hour. It will be uneconomical to design the roadway facilities for the highway hourly traffic volume. Therefore, a reasonable value of traffic volume is decided for the design, and this traffic volume is called the design hourly volume. So the design traffic depends upon the rate of growth of traffic, the design period, importance of road in the system, nature of roadside development, and many more. So this is the equivalency factor for various type of vehicle. So example is fast vehicles, so motorcycle, scooter, so 0.5, and for slow vehicles, cycle is 0.5, and many more. Then the third one is the design speed. So design speed is defined as a selected speed to determine the various geometric features of the roadway. Design speed depends on the functional classification of the highway, the topography of the area in which the highway is located, and the land use of the adjacent area. For highway design, topography is generally classified into three groups: to level, the rolling, and the mountainous terrain. So this is a level terrain. So ang level terrain is relatively flat. Horizontal and vertical sight distances are generally long or can be achieved without much construction difficulty or major expense. Next is the rolling terrain. The rolling terrain has natural slopes that often rise above and fall below the highway grade with occasional steep slopes that restrict the normal vertical and horizontal alignments. The next is the mountainous terrain. So it has sudden changes in ground elevation in both the longitudinal and transverse directions, thereby requiring frequent hillside excavation to achieve acceptable horizontal and vertical alignments. So the design speed selected should be consistent with the speed that motorists will expect to drive. So this is the minimum design speed for rural collector roads. So, magtanaw ka dira kung unsa nga type na terrain like for level. So 40, 50, and 60 rolling, 30, 40, 50, and mountainous 20, 30, and 40. And this one also is a design speed is selected to achieve a desired level of operations and of course the safety on the highway. It is one of the first parameters selected in the design process because of its influence on other design variables. And the fourth one is the design vehicle. So a design vehicle is selected to represent all vehicles on the highway. Its weight, dimensions, and operating characteristics are used to establish the design standards of the highway. So the different classes of vehicles and their dimensions were discussed in Chapter 3. So the vehicle type selected a design vehicle is the largest that is likely to use the highway with considerable frequency. The selected design vehicle is used to determine critical design features such as radii at intersections and turning roadways as well as highway grades. So the following guidelines apply when selecting a design vehicle. So first is when a parking lot or a series of parking lots are the main traffic generators, the passenger car may be used. Second is for the design of intersections at local streets and park roads, a single unit truck may be used. Third one is at intersections of state highways and city streets that serve buses with relatively few large trucks, a city transit bus may be used. Next is the cross-section elements. So the principal elements of a highway cross-section consist of the travel lanes, shoulders, and medians for some multi-lane highways. Marginal elements include median and roadside barriers, curbs, gutters, guardrails, sidewalks, and side slopes. So this is a typical cross-section for two-lane highways. So makita natin na ang shoulder, ang lane, then mga natural ground siya. Next is this is typical cross-section for multi-lane highways. So half section ni siya. So kita dali ang inside shoulder, the median, the variable width and design, roadway symmetrical, about center line, then cut or fill, and then we move to the width of travel lanes. So travel lanes will usually vary from 9 to 12 feet. Most arterial have 12 feet travel lanes since the extra cost for constructing 12 feet lanes over 10 feet lanes is usually offset by the lower maintenance cost for shoulders and pavement surface, resulting in a reduction of wheel concentrations at the pavement edges. Next is the shoulder. So the shoulder of a pavement cross-section is always contiguous with the traveled lane so as to provide an area along the highway for vehicles to stop when necessary. So in some cases, bicycles are permitted to use a highway shoulder, particularly in rural or collector roads. Next is a median. So a median is a section of a divided highway that separates the lane in opposing directions. The width of a median is the distance between the edges of the inside lanes, including the median shoulders. So the function of a median include providing a recovery area for out of control vehicles, separating opposing traffic, providing stopping areas during emergencies, provide storage areas for left turning or U-turning vehicles, providing refuge for pedestrians, reducing the effect of headlight glare, providing temporary lanes and crossover during maintenance operations. And the next is the roadside and median barrier. So a median barrier is defined as a longitudinal system used to prevent an errant vehicle from crossing the portion of a divided highway separating the travelways for traffic in opposite directions. So roadside barriers, or on the other hand, nagaprotect sila sa vehicles from obstacles or slopes on the roadside. Next is the curbs and gutters. So curbs are raised structures made of either Portland cement, concrete, or bituminous concrete or rolled asphalt curbs that are used mainly on urban highway to delineate pavement edges and pedestrian roads. So curbs are also used to control drainage, improve aesthetics, and reduce right of way. Curbs can be generally classified as either vertical or sloping. Next is the guardrails. So guardrails are longitudinal barriers placed on the outside of sharp curves and at sections with high fields. So their main function is to prevent vehicles from leaving the roadway. The next is the sidewalk. So sidewalks are usually provided on roads in urban areas but are uncommon in rural areas. So nevertheless, the provisions of sidewalks in rural areas should be evaluated during the planning process to determine sections of the road where they are required. Next is the crossslopes. So pavement on straight sections of two-lane and multi-lane highways without medians are sloped from the middle downward to both sides of the highway, resulting in a transverse or cross slope, with a cross-section shape that can be curved, plane, or combination of the two. So, ano siya, ang typical highway curve. So we have the vertical curve and the sloping curves. Ay. Then this one is the basic cross slope arrangement for divided highways. So natay pavement slopes for two ways and then pavement slopes for one way. The next is the side slopes. So side slopes are provided on embankment and fields to provide stability for earthwork. And also side slope also serves as a safety feature by providing a recovery area for mga out of control na mga vehicles. So this is the guide for earth slope design. So flat or rolling ba siya, moderately steep or steep, and then height of cut or fill. Kailangan mo na siya na table. The next is the right of way. So right of way is the total land area acquired for the construction of a highway. The width should be sufficient to accommodate all the elements of the highway cross-section, any planned widening of the highway, and public utility facilities that will be installed along the highway. So in some cases, the side slope may be located outside the right of way on easement areas. So the sixth factor is the presence of heavy vehicle on steep grades. So the effect of grade on the performance of heavy vehicles was discussed in Chapter 3, where it was shown that the speed of a heavy vehicle can be significantly reduced if the grade is steep and or long. And in Chapter 9, it was noted that steep grades affect not only the performance of heavy vehicles, but also the performance of passenger cars. In order to limit the effects of grades and vehicular operation, the maximum grade on any highway should be selected judiciously. And then the seventh is other factors. Other factors are the level of service, the available funds, the safety, the social and environmental problems. So that's all. Thank you for listening, please, everyone. Bye.